Welcome to experiment 2. In this lesson, we are going to build a simple pendulum and demonstrate that science is replicable. We will repeat the experiment multiple times and show that we get consistent results. This experiment beautifully demonstrates the principle of replication in science. Let's begin. Our aim is to show that if we repeat an experiment using the same method, we get the same results. Our hypothesis is that a pendulum with the same length released from the same angle will take the same time to complete 10 swings each time we try it. This experiment demonstrates replication, that is, repeating an experiment to ensure results are reliable. It also demonstrates consistency and reproducibility. These are fundamental principles of science. Let's see what we need. Here is what you need: a steady string or thread. It needs to be strong enough to support the weight. A small weight like a metal ball or stone, a ruler or measuring tape to measure the length of the string, a stopwatch to measure the period, and a stable point to hang the pendulum from, a hook or the edge of a table. Make sure the hanging point is secure so the pendulum doesn't fall. Safety is important. Safety is important. Make sure the hanging point is very secure. You don't want the pendulum falling. Make sure the weight won't fall on anyone. Keep the area clear of people and objects. Don't swing the weight near your face. Use an appropriate weight, not too heavy. These precautions ensure a safe experiment. Let us build and test the pendulum. First, attach the weight securely to one end of the string. Then you hang the string from a stable point. You measure the length from where the string is attached to the center of the weight. Hold the weight at a 45-degree angle and release it. Start your stopwatch as you release it. Count 10 complete swings, that is 10 times the weight goes back and forth. Record the time, then repeat the experiment 2 more times with the same string length. Record all your times. You should get very similar times each time, demonstrating replication. Here is your data table. Keep the string length the same for all 3 trials. Only change the trial number. Record the 10 Record the time for 10 swings in each trial. Then calculate the average time. You should notice that the times are very similar. This demonstrates replication. When you repeat an experiment with the same method, you get the same result. This is a fundamental principle of science. Here is what you should expect. Your three times should be very similar. For example, you might get 2.0 seconds, 2.1 seconds, and 1.9 seconds. Small variations are normal because they are due to timing errors or slight differences in how you release the pendulum, but the times should be close together. This demonstrates replication. If you repeat an experiment with the same method, you get the same result. If your times vary, think about what might have caused the difference. Did you keep the string length the same? Did you release the weight from the same angle? These questions help you think scientifically. As you conduct the experiment, observe carefully. Are the times the same each time? What causes any differences? How consistent are your results? Does the pendulum swing smoothly? Then write your conclusion. State what you found. Explain how this demonstrates that science is replicable. Discuss how repeating the experiment confirms the reliability of your results. This is how scientists communicate their findings. This experiment demonstrates several characteristics of science. It is replicable because we got the same result when we repeated the experiment. It is consistent because the results were predictable and reliable. It is methodical because we followed clear procedures, and it is verifiable because anyone can repeat this experiment and check our results. This make this is what makes science trustworthy. Thank you for watching this pendulum experiment. If you try this experiment, share your results in the comments. Tell us what period you measured. In our next lesson, we'll conduct a third experiment on starch in plants that demonstrates methodical nature of science. See you then.